Now we're going to get a cleanup update from Jack Zimmerman.
Thanks for letting me put you on the spot. Thank you. Yep, it's on. All right, everything working okay? Sounds like it. So thanks, Bobby Joe. For those that don't know me, I'm Jack Zimmerman. I'm the excuse me, manager of the Idaho Cleanup Project. Bob did mention an organizational change in his briefing, but I don't really see any change really in the function of how we operate here. I think we'll continue to do, a very collaborative relationship between the Office of Environmental Management, the Office of Nuclear Energy, and which really relates also to, I think, a collaborative arrangement between the contractors, Fluor Idaho, as well as Battelle Energy Alliance. But going in with today's presentation, we've got a lot of progress, a lot of things that are coming to completion, either recently or in the near future. I'd like to really emphasize some of those things here today. One of the bright spots really is the progress in the buried waste. This is primarily transuranic waste, targeted transuranic waste, which was not generated on site necessarily. The vast majority of that waste came from off-site, such as Rocky Flats, in support of the weapons production program back during the Cold War era. Originally, when this material came on site, it was buried, covered in dirt. Nobody thought they'd ever go get it again, but over time, realized that this is not the best disposal means for material like that, especially given the location of the Snake River Plain aquifer. So we've been exhuming this waste for over the last 12, 13 years now, and we are coming to an end shortly. As you can see from the curve here, this is just the straight line curve where we need to be to hit the agreement in principle target dates in 2023. We think we're about 2 years ahead of schedule with regard to that. And recently, photograph up here, this is ARP-8. It's the Accelerated Retrieval Project, number 8. So basically, we built enclosures over each one of these pits so that we would be able to contain the material as we dug it up, because as you can imagine, over the last 50 years, we find waste in various conditions. Some of it doesn't have there's no drum left, and we just have to dig it up just like dirt, so there really wasn't containment. So the ARP structure provides a very important safety feature, provides protection for the environment as well as the workers. But this ARP-8 was the last one. This is some exhumation that's going on inside of ARP-8. That was completed in March. So we finished ARP-8, and ARP-9 is the very last one that we have to do. And here's a picture of ARP-9 before we started exhuming the waste. This is kind of what that would have looked like a long time ago. But here we've got about 0.69 acres remaining, and we will finish that project. We also had a minimum commitment of waste to be exhumed. We actually hit that target at the end of last year. So we've hit the target as far as the volume of waste that was required, about 7,485 cubic meters to be exhumed. But we also had a commitment to also a physical area of waste that we would exhume. And so that's what we're continuing to work to. And we, like I said, we expect this project here. They started exhuming the waste in April. We think it's probably going to take somewhere in the next year and a half, 2 years max. So another area, just a small victory, but an incredible effort. We worked with the state very collaboratively to repurpose an area because we had large boxes of waste that are tied to the Idaho Settlement Agreement, transuranic waste. And that transuranic waste had a similar origin, not most of it off-site. But now that we are down to the very end of that project, we're dealing with some of the most difficult and hardest things to do. So the large boxes, we had no capabilities to treat that waste that existed over at the Advanced Mixed Waste Treatment Facility. So collaboratively worked with the state to repurpose one of those ARP structures where we had finished the exhumation and use all the structures and the safety systems that were in place there to go ahead and take on these large box project. Really that saved quite a bit of time as well as funds because we didn't have to recreate new facilities with new safety structures. We were able to repurpose excess facilities. And so that's really just an example of, I think, how we're able to collaborate with the state in finding, cost-effective, creative, and safe solutions to these problems. But in these boxes, they were too large to fit in the treatment facility as is. It was also, some of these boxes came from the mound site, which dealt with basically the space isotope power production before that mission was moved to Idaho. And so they dealt with plutonium-238, which is a very hazardous and difficult, isotope to work with. It's very mobile, friable in air. And some of the things they saw in here were numbers I've never heard of, and I got some numbers on the other page, but there was 789 billion DPM of contamination on these glove boxes. So working with that was critical to have these kinds of safety systems in place. So you can see the workers are protected. We have multiple barriers of protection. That effort's now complete. They have resized all of those boxes so that they fit inside the treatment facility now. And the first batch of those has gone through the treatment facility already. And so that's a significant achievement, just another small step into the overall one. Which is going to have the treatment facility will be wrapping up its mission this summer, probably in the July timeframe. So again, in the progress in the transuranic waste, talked about the treatment facility. That, we are wrapping up that mission in July with regard to the Idaho Settlement Agreement waste. We think that it'll continue to operate for a few months beyond that with some of the other low-level waste and things that would have a purpose. So I think you've seen a lot in the press. So there was a voluntary separation that was announced and is now over. But there are enough volunteers and an attrition that we'll be able to avoid an involuntary separation in the June timeframe. So right now the treatment facility runs on a 24/7 schedule. When we finish the Idaho Settlement Agreement transuranic waste mission, we'll step that down to a 7/12 schedule. And then we'll wrap up the low-level waste and some of the other odds and ends that have to be cleaned up to just completely finish that mission. And in the September timeframe, we will step it down to a 5/10 schedule. And at that point, it's probably going to be impossible to avoid an involuntary separation. But we will be running another voluntary separation in the August timeframe. We'll see who volunteers and then see where that takes us. But we do have other things, I'll get on to a little bit later, some of the things we're going to look at accelerating or starting up, which could minimize some of the impact on the workforce. So right now, this picture up here shows we've got about 40,000 drums of treated transuranic waste that is awaiting the certification and shipping to WIPP. So we continue to be the largest shipper of waste to WIPP. We routinely get between 6 and 9 shipments per week. Right now, WIPP is only running at 10 shipments per week. So we are allotted 5, and then we pick up any extra shipment that we can, just maintain a state of readiness and keep our numbers up as far as shipping that waste out of Idaho. But right now, sequenced with the WIPP shipping schedule, we don't anticipate we're going to finish that shipping of that Idaho Settlement Agreement waste for about 8 to 10 years, depending on that shipping schedule. And again, I think we've already talked to one of the other areas. We worked with the state is on with sludge waste. That was another waste form that wasn't suitable for the treatment facility, but we repurposed existing facilities with the right engineering controls. That's also where the ARP 5 event happened about over a year ago at this point. So we've resumed processing the material that's in ARP5, and that started up last month. Then we are looking at moving that material over to ARP7 when I guess we're working on the permitting aspects of that now, but are looking at restarting that sludge waste treatment over in ARP7. And that material, there's just about 500 cubic meters of the sludge waste. That is also Idaho Settlement Agreement waste. But with the controls, additional controls that we've put in place, we're expecting that's going to take a bit longer to process the rest of that material. And it's likely to take about a year and a half also. So there's a lot of activity and a lot of completions and steps we've got. And so looking towards the future, those activities that I talked about all took place here at what we call, it's the Radioactive Waste Management Complex. That's what RWMC stands for. SDA is the subsurface disposal area. So this is what it looks like today. Here's the treatment facility. This is the stored transuranic waste where it was above ground. These areas are the ARPs and where the waste was buried below the ground. And so as we wrap up these missions, what we're looking at is basically pulling up the closure of this area. We've been, as long as we can assume that we've got some stable, flat funding, we think we're going to be able to pull up the closure of this area by perhaps up to 10 years. So that's our first focus. So what we're going to be looking at is basically going through the RCRA closure of this process, a couple of these repurposed facilities. Then we'll be going through a D&D phase where we take all the structures down. And in the end, it's going to look like this. Basically, there will be a cap over the entire area, which is an evapotranspiration cap. It's going to be using natural vegetative cover to maintain the balance in the environment and prevent moisture infiltration down to any of the residual material that's left. And so we are looking at accelerating this up to about a 2028 completion date versus a date that was more like 2038 previously. We think all that's achievable with where we're going and the progress we've made so far, and would be appropriate to accelerate those activities. Again, on IWTU, of course, that's one we've talked about a lot in the past, but the Integrated Waste Treatment Unit, the purpose of that facility is to treat some of the decon solutions that were used to clean out the fuel reprocessing facilities when they were shut down. That's what makes this liquid waste very, it's more difficult than the material that went through the calcine facility. Right now, we're in a simulant run. I think, last simulant run, we proved some of the fixes associated with the process flow sheet and primarily the issues we had with fluidization of the denitration mineralization reformer, which is the primary reaction vessel for that material. So right now, we're on day 36, I think, of the run. Everything looks real stable with the operations. I spent a number of hours out in the control room, talked to the operators, and it was probably the calmest control room I've ever been in, to be honest with you. There was just not there at least a couple hours, and there wasn't really a single alarm or alert condition that came in. The purpose of this run really is to, one, prove that we can operate the facility in a sustained manner, but we also have 14 tests that are designed to test the operating boundary conditions of the plant. So we're taking the plant to the boundary of the operating envelope and proving that we can recover from that condition and bring it back into the midpoint or the stable point where we want to operate. I think the good news about the good news about the problems IWTU has had is that's probably the most ready and skilled workforce that's going to start up a new nuclear activity ever, because of the experience that they've gained from all the technical issue resolution and the simulant runs. It's a very highly skilled and ready workforce. And so some of the other focuses we have at this point, we're past, I think, the process conditions. We know that IWTU will work. We know that it will make the intended product, but we have to make sure that it's ready to sustain radioactive operations. So some of the improvements that we have in line are in line with improving the rad ops capabilities. One right here, this is a mock-up of the dry decon system. This is an example of what the canister decon system is going to look like. Basically, those canisters that come out, have to basically on the exterior be completely contamination free. So this is kind of a backup to make sure, just in case there was, we're dealing with dry material, just in case a spec came off, we have the ability to recover that. It almost has to be done remotely because the dose rates associated with these canisters are going to be very high. It's not an activity you would want to send a worker in to have to go in and do manually. So robotics are key to the success of that particular issue. The other piece we're working on is the design and testing of the wet decon system. And that's basically a way, if the process vessels, there was an upset condition where we couldn't empty the process vessels, we have basically an acid solution that would be able to dissolve the material and recycle it back to the waste feed tank, and ultimately it would go through the process again. And the reason that's critical, because if we did have the upset condition and we had to go in for a maintenance or a repair activity, again, that's a very high dose rate. So this will let us clean the vessels out and significantly reduce the hazard to the worker associated with that. And right now, the only key technical issue with regard to the process remains finding the engineering solution to the filters that are in the process gas filter. That was an issue I think you heard about in the fall, but it came up in the last simulant run last year that the PGF filters really aren't doing a very good job. It's a high temperature corrosion issue that basically leads to the plugging of those filters. And we're starting to experience some of that even with these. We had a spare set of filters we were able to use for this run because that was the right approach. While we've got a Hazen facility, it's a pilot plant facility out in Colorado, which is testing 4 different filter media to try to figure out which one works the best. Fluor Idaho will then be down selecting and we'll deploy what is the best solution associated with the filter issue. But the technical review group that we have includes members of the national labs, the commercial industry. We got a lot of great experience advising us on that. They do believe that issue is basically an engineering issue that can be solved. It's not really going to be a technology development issue like a lot of the ones we've gone through in the past. So it's just going to take time to prove what works and then deploy it out in IWTU. So at the end of this simulant run, we're actually now we're working on test condition number 10. So I'm pretty sure we're on track to successfully complete the testing in around the 50-day period. But the next step after that is going to be an outage. It's a pretty extensive outage. We are going to be installing the decon systems I just mentioned, as well as the fix on the process gas filters in that time. Another area, as far as the progress we're making with the spent nuclear fuel, our whole focus is on moving that fuel from wet storage to dry storage by 2023. That's our commitment. Recently, we completed returning some of the fuel back to the Naval Reactors Facility. So it's another completion. We finished that project. The interesting thing about that project is, it covered a pretty wide variety of time. There's been a collaborative relationship between the Navy, Naval Reactors, and the lab for many decades. And I found out, at the end of the project, it was brought up by Naval Reactors that some of the fuel that was returned over the life of that project originated in the Nautilus, which was the very first nuclear submarine. So it's also a project that ties to some historical significance. But one of the areas so we are on track for that completion. We have some advanced test reactor fuel that's in wet storage in EM space. We're moving that over to dry storage. And then also we have some experimental breeder reactor 2 fuel storage fuel that's still in wet storage. That's going to go on till about 2023 before we finish that. But the ATR fuel will probably finish up in the 2021 timeframe as far as the transfers. So we've got some incremental steps to getting to successfully completing that milestone. And then one of the things that we've worked, this is another collaboration between really the lab and the contractor, EM and NE, but they've developed an innovative way to place some of the ATR spent fuel that's generated from ATR, and we would be able to put it in dry storage over in our facility in 603. And they needed to find one way to deal with it is, that fuel it comes out hot, so this would shorten the cooling period that fuel would require before it gets moved over to dry storage. It also increases our storage capacity with that configuration. So it was a good innovative solution with all the parties working together. And this is a new slide, I think, for what I'm showing the line, but I have to thank Mayor Casper and Dana as well for helping develop this. It kind of came on the back of a napkin one day as just an easy way to try to show on the EM side all the different kinds of waste that we have and what we're working with. And I think it's kind of a one-sheeter with a lot of information. I've touched on these, but the high-level waste, basically that material came from the reprocessing of spent fuel. Most of that originated on-site. Well, really all that waste originated on-site. It's been calcined now. It's stored as a solid. The spent fuel came from various sources, commercial, research, as well as on-site. And that's the material that we were all, trying to complete the movement to dry storage, then ultimately off-site for permanent disposal or a temporary repository if available. The transuranic waste, that's the focus of our mission. All that's coming to an end shortly. But I told you about the origin. Most of that stuff came from off-site. A small quantity from the Idaho National Lab operations. And like I said, we plan on completing all of that mission, really by the 2021 timeframe. And then it'll be primarily a shipping mission after that. Sodium-bearing waste we just touched on. Again, that was really decon solutions that came out of the clean out of the processing, the spent fuel reprocessing equipment. So again, that's problematic, but that's the only liquid waste we have left on site on the EM side. And as we get IWTU running, the real purpose of that facility is to convert that into a dry form that would be suitable for disposal. And then the buried waste, again, we talked about, it's very similar to transuranic waste. Well, it is the transuranic waste, very similar characteristics. It was just buried instead of stored above ground. So it kind of gives you also the amounts that's shipped and how much we have left on site. So it's kind of a handy tool. Now, I guess we got a video that Fluor developed. So recently, in the March timeframe, the Idaho Cleanup Project was the feature site at Waste Management, which is kind of an annual get-together for the entire complex. And it's also happens to be 30 years of EM as well. So it was a dual celebration. Fluor Idaho worked with us to put this video together. It was shown at the conference, and maybe this won't work. Anyway, and it shows 30 years, the 30 years of progress we've made from just a tremendous amount of progress over the last 30 years. And you can see over the next few years, we're going to be finishing a whole lot of those things that have been started.
Hi, I'm Eric Simpson. In the early days of the cleanup program here at Idaho, the focus was really on completing environmental assessments. And then once that was done, we tackled some of the lower risk sites first, which had some contamination and some debris. As we gained more experience, we moved up to much more challenging projects.
I'm Cliss McNeil. Test area north today is almost entirely gone. It's just a really good example of something that truly was taken back to the barren ground from all of the facilities that were originally placed there.
We used those skills on some of the higher risk sites.
If you look at the radioactive waste management complex, We've made great strides in getting rid of a lot of the true waste that was sent to us from the Rocky Flats facility.
I'm Jason Chappell. The waste we are exhuming are 6 specific targeted waste streams that pose a hazard to the environment and pose a hazard to the aquifer that is 600 feet below us. As each exhumation facility has been constructed, we have incorporated those lessons learned from previous endeavors and utilize them to benefit how we go forward.
Hi, my name is Nathan Loftus. So about 15 years ago when we started out here, this building was full of little over 100,000 containers, from boxes to drums with about 2 to 3 feet of soil on top of it. We transformed this facility by bringing in a workforce that was able to remove all the soil off these containers and safely be able to retrieve each one of these drums, characterize it, and prepare it for shipments to WIP.
If you walked into Intech today, the progress that's been made there is enormous.
I'm Pat Spalding. An example of cleanup progress is the mound of dirt behind me. It was once a reprocessing facility built back in the 1950s. It has now been demolished. Another example is the spent nuclear fuel that we are currently taking out of the wet and putting it into dry storage. What I'm most proud of is just the success that we've made in meeting the settlement agreements, and we're getting close to the end, and it's a good feeling.
What I'm most proud of being on the Idaho Cleanup Project is how we as employees with very diverse backgrounds and technical skills have come together for a common cause, the completion of our mission, keeping the commitments that have been made to the citizens of Idaho.
Right. Anyway, I think it's a good video that, that shows you some of the progress that's been made. I just want to close in pointing out one probably important thing that, you know, as you saw, Test Area North, that area, basically EM's essentially complete there. I showed you the acceleration opportunity we're looking at the Radioactive Waste Management Complex. So by 2028, I expect that we will have shrunk our cleanup footprint down to just one area left at the site, and that's going to be at Intech. And at Intech is where the high-level waste and the spent fuel resides. And part of the problem with that is, there's a lack of a repository, where we're going to be able to send that material. So there's a lot of uncertainty in, some of the steps forward we have to take to finish that area. But we will have shrunk it down to a minimal footprint by the 2028 timeframe. Great. So, any questions?
Thank you, Jack. Yeah, any questions? Director Tibbetts?
Thank you, Jack, for your presentation. And I was particularly interested in the update for the IWTU unit. I'm pleased to hear that the simulant run is going well. I think that I recall that the plan is that this would be the last simulant run. Is that correct? And I want to ask you if my assumption is correct, that if that's true, that so far this simulant run has not indicated any concerns that would lead to the need for an additional simulant run.
Well, you are correct that is the current plan. They need to evaluate the data from the simulant run, and I think the only thing that would drive us to another simulant run is going to be based on the resolution on the PGF, the process gas filters. Excuse me. And just to be clear, though, the plan, there really was a 30-day simulant run right before radioactive operations that has been in the plans, but we would roll straight into rad ops at that point.
Thank you. Madam Chairman, just one follow-up, if I may. So, Jack, you seemed to be pretty confident that the current issue that you're experiencing with the filters, I think you mentioned that it was really a technology issue. So is there a fairly high level of confidence that issue will be resolved?
Yes.
Okay, thank you. Appreciate that.
Thanks. Director Keeley?
Jack, great presentation as well. And again, a newcomer to this commission. It's the INL is a major contributor to the economy for Idaho. And between Bob's presentation and yours, can you tell me roughly the split between the waste activities versus what I call the new reactor activities versus our other science that's going on with cybersecurity. So as you're looking to wrap up the historical and waste activities soon, what impact might that have on a reduction for the economy here that might be replaced by the SMRs or other activities? But starting today, what kind of split is there in terms of activities with waste versus the others?
Well, today I can say that on the cleanup side, our annual budget is around $430 million per year out at the site. And Bob, I don't know if you want to speak to your annual budget, but I think it's like 1.2 billion or so.
The the annual budget of the INL is 1.4 billion. So.
All right, so we are, about 25% probably of the total impact out at the site right now is EM. But we are looking at if we continue, at that 430 level, we are going to be able to accelerate some of the completions at RWMC, but there will be, depending on what decisions are made with regard to the high-level waste and spent fuel, I can't really speak beyond the 2028 timeframe.
Mayor Casper.
Thank you. I always appreciate the comprehensive nature of your briefings and updates, so thank you for what you've shared. I just have a question. It seems to me the ARP-5 canister rupture that happened, I can't even remember exactly when now, but over a year ago, I have not seen, I know that the study's been done, it's been resolved and all of that, but I haven't seen a final report. Has that, did I just miss it, or has that been completely resolved and put to bed?
I guess it depends on what you mean by final report. So the investigation and all the technical analysis that went into it, that was finalized, and I think it was issued in November of last year.
Okay.
And from that, we developed the actions and process improvements that we needed to put in place. Then we had to go through a permit mod with DEQ, which was just recently approved. And that's why we just recently got back into work in that area.
So if I could, what was the distribution on that report that came out last November? Maybe that's what I missed.
I guess I'll have to find out.
On the website.
Oh, you're right. Yeah, it's also on the CAB website. So there was a CAB briefing on the results, and then after that it was posted on the website.
Thank you.
Great. Any other questions? Admiral?
So Jack, at some point, it goes on now, there's long-term environmental monitoring that will continue for as far as the eye can see. So even when you're done with your work in 2028, there will be ongoing environmental monitoring programs. To my knowledge, DOE has conducted that monitoring through the use primarily of contractors. I'd offer that we ought to consider using some institution that's in the state, that's part of the state and not of the federal government and from outside of Idaho, if not the primary role, a secondary role, so that everybody in Idaho stays attuned to the environmental monitoring that's going on, and we do that so we find out what we don't know. So did we find out something we don't know? I think, again, I don't think that's ever been done, and at least my opinion is the institutions within the state that would be a good place to build that capability would be the universities, because they have the science and engineering and technical backup to be able to meet DOE's needs. So I don't know if you've thought about that.
We certainly haven't thought about it in the short term, and I guess it is something we could explore. But you're right. Right now, the contractors are the prime source of it. DEQ does some of its own independent monitoring, and also we have there's a grant with the Shoshone-Bannock tribe where they may do some additional split sampling analysis as kind of another overview step. I think that certainly there's no reason we couldn't consider a different approach in the future, but ultimately EM basically goes away at some point. The lab mission is an ongoing mission, and that's already built in. So at some point, it would be a lab function, but that's still 2 decades away before we get into the long-term, basically monitoring.
Madam Chair, just one follow-up. One man's opinion on that. I think we ought to explore it because it would be a way to underwrite, public trust and confidence in a way that, as far as I can tell, nobody's ever done before. So we don't mind being first.
No, I'll take an action to take a look at that. I have no issues. I know other sites where EM has finished their mission and turned them over to legacy management, for example. I do believe contractors are still the prime resource for conducting the monitoring.
Representative Horman?
I am more familiar with the structure of the Battelle contract, less familiar with the contract on the cleanup side. Could you just provide a very high-level overview of the current contract structure?
Sure. Right now, the primary contractor on site is Fluor Idaho. That's a 5-year cost plus incentive fee contract, which means that there's milestones as well as if they save money in execution, we would split the savings, 80% to the government, 20% to Fluor. That allows us to reinvest the savings back into additional scope that Fluor might be able to conduct and pull in. Right now, it's about a $1.8 billion contract over that 5-year period. Now, unfortunately, when it was issued, there were no options were allowed. So we are now beginning, the process of looking at the follow-on contract period after Fluor Idaho. So it runs through May of 2021 would be the completion of that contract.
Well, thank you, Jack, and thank you, Bob. And I just want to take the opportunity to speak confidently on behalf of the governor's office and I believe the Attorney General's office as I look at Sherm. We just want to thank Department of Energy for the open lines of communication and engagement that we've seen since Governor Little took office, all the way up to engagement with the Attorney General and the governor. So thank you for that, and we look forward to continued open lines of communication. And with that, I think we are going to take a 5-minute break before we get into our panels.